What I have here is an Apple IIc computer that's been in my family since it was purchased new back in the 1980s. At some point, if I recall correctly, it stopped working and was put in a box and stuck away in the garage. It's been there ever since. I came across it the other day and decided I'd get it out and see if I could get it working again. So this video will document the steps I'm taking to get it to power back up. So the first thing I've done is connected all the wiring like it's supposed to be. We'll come in here and I'll turn the monitor on, and the monitor powers up, the light's on. So then we'll turn the switch on the computer, and as I suspected, nothing. There's no power there. So I will pause the video here and get set up to do some further diagnostics. So the first thing we want to check is the main power supply. So this is what comes with the Apple IIc. See if we can get a look at the bottom here. And so this says should be putting out 15 volts, 1.2 amps. So what I will do, plug that in, and I did go online, do a little research, and I found what the pinout should be for this connector. So I'll show you that here. So the website that I found that picture on has some other useful information, so I'll post a link for that with this video. So according to that picture, these two pins should be ground, and then these two pins over here should be 15 volts. I'm going to slide my voltmeter in here. Get rid of that glare. So I'll go ahead and put that on there, and this is telling me 4.9 volts. So I'll move that to the other pin. And again, 4.9 volts. So that is nowhere near the 15 that it's supposed to be. It tells me the power supply is not completely dead, but it is definitely not doing what it's supposed to do. So I will pause again and do a little more research and see what I need to do to get that power supply working. After doing some research online, I decided that that power supply was its own project to try and repair. It's not easy to take apart, and parts for it are not easy to come by. So instead I decided to just get like an aftermarket power supply. There are a few options out there. One of them is you can buy the plug and make your own adapter to adapt to a power supply you already have. I did not have one that was 15 volts, so I went ahead and just purchased one that's meant specifically for an Apple IIc that outputs 15 volts. I'll post the link to the website where I got this one from. And I have tested it. It does output 15 volts. So I'm going to go ahead and plug this one in. And then we'll try it, turn it on, and still nothing. So that tells me the power supply is not the only problem. There's something going on inside the computer. So I guess the next step is to take that apart. I'll pause the video again and get set up to do that. To open up the computer housing, you're going to need two tools. First you'll need like a #1 Phillips screwdriver, and then you'll also need what's referred to as a spudger tool, just a flat bladed tool. Some are plastic, some are metal. That'll help you break loose the connections between the two pieces of the plastic housing. So on the bottom there are 6 screws you'll need to remove. I've already taken them out, but I'll show you where they're located. So there's 2 screws on this side. There are 2 screws on the opposite side. And then there are 2 screws in the back. There are also 4 screws here that you do not remove. Those hold the disk drive in place. So it's not necessary to remove those to get the housing open. So we'll put that back here. So the spudger tool, you'll take that once the screws are out, get it into the casing in the front, and then that'll let you pop it open. And then you can work your way around and remove the housing that way. At the same time, there's a carry handle that'll come off, so you can set that aside as well. So here's what the inside of the computer looks like. So this is the power plug that we've been working with. So we're going to plug that back in, and I'll start doing some diagnostics on the inside to determine where the power is getting to and where it's not. Searching online, I was able to find some wiring diagrams for the inside of the computer. I'll post a link to where I found these. They're going to be extremely helpful. But I'm going to zoom in here. This is the computer side of the power plug. And if we look at, so this will be a mirror of the plug diagram. So this side, number 5 and 6, will be the 15 volt power, and then 2 and 3 will be the ground. We can denote that this is labeled plug J1, and this IIe is an indication of the circuit that it's on. So if I flip the page, I can see down here we've got J1, got the IIe, follow the path. This symbol is a fuse, labeled F1, and then from there it goes through, this symbol is like an inductor, and then this would be connecting to a trace on the circuit board to give 12 volt power, which will be 15 volts in our case. Then we can come over here and have that same connection, and this is labeled S1, which is the switch. So from here the power goes through. When the switch is off, you'll only have power on number 3. When you turn the switch on, it'll connect to number 2, so both sides will have power. And then there's a third terminal that's connected to a ground on the board. If we follow, after you turn the switch on, it'll come across to this one labeled FFF, and it's plug J11. And this would be pin number 12 on plug J11, and we'll look at that later. Needless to say, I could spend hours going through these diagrams, but they are available. They'll be very helpful in tracing this down. I'll reference them from time to time if I need to. But the first thing I want to do then is we'll look inside here. So right now I'm unplugged, so there's no power inside the computer. If you are messing around it here and we do have it plugged in, you'll want to be very careful not to touch the wrong thing with your probes. You could cause more damage, and then again, messing with electricity, there's always the possibility you could get a shock. So if you're not comfortable doing this, then I would say don't do it. I'm simply providing this video to show what I did, but not necessarily saying that this is what you should be doing. But if we look here, we've got L1, which was the inductor, and then right next to it is F1, which is the fuse. And then back here is this power switch. So we'll check for power going through those. The first thing I want to do, I think, is check and make sure that fuse is good. Really probably the very basics of everything. So I'm going to turn my multimeter on for a continuity check. So now the way this works, if I can do this with one hand. If I touch the probes together, and I get continuity and I get a tone. So if the fuse is good, touching each side of the fuse, I'll be able to get a tone through it, and that'll tell me that the fuse is good. So in this case, you can see that I'm touching both sides of the fuse, and I get a tone, so that tells me the fuse is fine. So for the next test, I'm going to need to plug everything in, get different probes connected, and actually start checking for power throughout the board. So I'm going to pause the video here for a second and get that set up. Okay, so I have a hook probe connected to the ground lug of the switch, so I don't have to hold that. That'll stay in place. I do have the power supply plugged in, and I have my multimeter set for checking voltage. And I'm going to say this one more time. Right now there is live power inside here. If I touch the wrong thing, it will arc across, could cause more damage, and I could also give myself a shock touching the wrong thing as well. So again, if you're not comfortable doing this, don't do it. The first thing I'm going to do is I'm going to test for power coming through the fuse. So I'm going to probe the fuse. And voltmeter gives me 15.5 volts. So from there, I'm going to move to the leg of the switch. So on that side, so that side of the switch, 15.5 volts. So I'm going to move to leg number 2 of the switch, which is the middle one. And that is 15.5 volts. That's because the switch is on. So if I turn the switch off, test that again, it's 0. So the switch is working correctly. So we'll turn that back on. So one more time, the middle leg, and 15.5 volts. So the next path of that power from the switch was to the J11 plug and terminal number 12 on that plug, which that plug is the one for this circuit board here. So what I'm going to probably do is remove this circuit board so I can test the actual terminals on the plug. To do that, we'll need to remove the keyboard, and I'll just show you. The keyboard just lifts up, and there's little tabs that you got to slide it out of, and then there's a ribbon cable you have to unplug from the board. And then this board itself, there are 2 screws, one right there and one on the other side. Have to remove those screws, and then the board will pull out towards the back of the computer, and remove it that way. So I'm going to go ahead and do that, and then I'll come back and show you where I'm testing. Okay, so on the diagram, we'll see that here is pin J11. If I go inside here to where I remove the board, you can see the J11 right here. You'll also notice there's a number 1 over here, and on the other end is a number 43, and then up here is a number 2, and then on the other end is a number 44. And so that's indicating the numbering of all these pins. So on the outside, all the odd numbered pins are on the outside, and then the other row on the inside is all the even numbered pins. And so if you notice, the top row, or this outside row, connects to the top connections of the plug, and then the inside row connects to the bottom. So if I come back to here, I see pin number 1, and then 2 is across from it, and then you got 43 and 44. So really what I need to do to match the way we were just looking at is if I flip this around. So now we've got, get my wire out of the way here. So all the ones on the outside then would be grounds, and on the inside you've got 2, 4, 6, 8, so on up to 44. And those are telling you that these are grounds. These are 12 volt negative, which A little more research tells me that this circuit board is a power board, which is taking that 15 volts and stepping it down to a true 12 volt, and it's also stepping it down to 5 volts. It's using both of those. So this is ground for the 15 volts. This is the negative side of the true 12 volt. Here we've got the FF coming in. This is from the switch. So when the switch is on, this should be powered. Here's your 12 volt positive. And then these are grounds. And then you've got your 5 volt positive and negative. And then more 12 volts. So we'll be able to test all those in here. Some of them go through the circuit board and come back out, so all we can test now with the board out is any power coming in to the circuit. Something I wanted to show you on this circuit board is that the top of the board does not have any traces or contacts where it plugs into the connector. All the connections are made on the bottom. So what that tells me is that the top row of connectors that go to this outside one that were all labeled ground don't actually connect anything. They're just there to help hold the connector in place so it can be soldered in, but they're not actually being used. So what I want to do is then check for power on the bottom row. The first one I'm going to check is number 12, which is, these are all even numbers, so 2, 4, 6, 8, 10, 12. This was the power coming from the switch. So probe that one, and right now 0 volts. The reason is the switch is off. So I'll go ahead and turn the switch on, and then we'll check that one again. 2, 4, 6, 8, 10, number 12. And there I've got 15.23 volts. So the switch is working, power is getting to the connector. Also the next ones over were just 12 volt power coming in, and those would be on all the time, but directly from the power supply. So this one should read what the power supply is outputting. So that one's reading the 15.2 as well as the next one, and the next one, and the next one. So all those are reading 15.2 coming in. So those are all the incoming power to that connector. Everything checks out. So that part's good. So the next thing to do would be to put the board back in and then check for the power coming out of the board. That's going to be a little more difficult, but I'll go ahead and set that up, and then we'll do that. The circuit board's back in, so now what I need to do is test the connections on the inside of all the that connector. So what I need to be able to do is reach the probe through there and touch each of those legs. So to do that, what I've done is taken my test probe and covered it with some shrink wrap and just left the very point exposed. That way I can reach in there without worrying about touching the top row, and be able to test for voltage on the lower one. So if I look at the diagram, should be the third one from this side, so it's actually number 40, 38, 40, and 36. So starting at 44, so it'll be the third one over. If I reach through there, make contact with that one, should be reading 12 volts, but I'm getting nothing. The next one over should be the same thing, should be 12 volts. So make good contact there, and again, nothing. So that's telling me that maybe that board is not functioning. So that one should be 12, but it's not. This one should be 5. And get on there without slipping off. So that one should be 5, and it's nothing also. That one should be 5, and no. Again, no. So that's telling me that the 12 volt and 5 volt power supplies that are supposed to be coming from this board are not functioning. So I guess I need to decide what to do to fix that. So I spent some time online trying to decide what to do with this power board. One choice would be to find one just like it that is actually functioning and buy that and put it into this computer. What I was finding was most of them were a couple $100, with shipping probably a little more than that, probably a little more than I want to spend since I wasn't sure if there was anything else wrong with the computer or not. Another choice would be to try and repair this one. That would entail figuring out what on this board is not functioning and replacing it. That would be probably pretty time consuming, and I'm not sure I even have all the necessary tools to test all these different pieces on this board. So the other solution I came up with is, what if I just make my own little cheater board? So what I've done is, based on the diagram and what I found from other online sources, what that board is doing is taking the 15 volts coming in from the power supply, the external power supply, and just converting it to a set 12 volt and a 5 volt and sending it back out. So what I did is bought some little inexpensive components. So this one here is taking that 15 volts and it's turning it into 5 volts. And then this one here is taking the 15 volts, turning it into 12 volts. And then down here is a relay switch that is being activated by the power switch, the way I've got it wired in. So then this will turn on these other two. So the thought is that these components here will replace everything on that board. I had to mock up a little circuit board that I could plug into the PCB plug on the motherboard. But we should go ahead and give this a try. Now, one other thing I did find out while I was setting that up was that my monochrome monitor that's meant with this computer, even though it turns on, the power light comes on, I don't have a picture. I tested that on the side, and that'll probably be my next project, is trying to figure out what's going on with that monitor. So in the meantime, what I had to come up with was, I found a little portable television that has a video input with an RCA plug. So we will go ahead and I'm going to put a disc in the drive. Got it. TV's plugged in, power supply is plugged in. So I'm going to go ahead and turn the power on. Turn the TV on there. Disk drive is running. And there we've got an output from the computer. So what I've done here, pretty simple. It does work. I wasn't going to go into it in a lot of detail in this video, basically because this was just really kind of intended for a test, just to see if the rest of the computer worked. Right now it's, I'll admit, it's pretty ugly. It was just a prototype, like I said, just to try and get power to the rest of the computer to make sure everything works. So for now, I'd say the computer works. I might do some more testing, check out the keyboard and see if I can round up a couple more discs and try a couple different things in there. But what I really want to do next is actually just clean up the case and get the yellowing off the case and get the keys and the keyboard cleaned up. But for now, I've got a way to run the computer. I know it works, and so now I get to make the decision on how I want to proceed. If I do decide to stick with this, setup. I will probably clean it up a little bit, get the wiring straightened out a little better, get it set in there, and get it a little more permanent. If I do that, I'll probably make another video of just that part of it. So if people are interested in seeing that, go ahead and comment on this video and let me know you're interested in that, and that'll help me decide what I would do for the next video. Otherwise, I will probably also post something on the repair of this little monitor, depending on what I find there. Hopefully I can get that up and going. I'm hoping it's something simple, but you just never know until you get into it. So thanks for watching, and good luck with your project.